Hey everybody, I had a request for a one sample t-test, so I thought I'd try to do one of those really quickly for you guys, just so you have that. I know I did the independent t-test and the dependent t-test, so having a one sample might be helpful just to be able to see all of them. So here's what you've got. We are doing a study where we are going to put some students in a running program, and then we're basically going to compare their anxiety scores to people or students in general. So our hypothesis is that students in the running program are going to be less anxious than students in general. So you can see that reflected here. I have my two populations. I have my research hypothesis saying that people in the running program will be less anxious than people in general, and my null hypothesis basically saying the opposite. Information from the problem would be that the population mean, so anxiety for students in general is going to be at a 6. My N is 4. I'm making it very small here so our math is really simple, but essentially we only have 4 people in this running program, so there you go. We are going to need to find the mean for the people in our running program, the variance, the standard deviation, and the standard error. So if you're trying to do this just to make sure that you can do it on your own, I would probably pause right here and just write down all this information, write down the 4 scores for the people in the running program, and then pick back up. So I'm going to sit here and do this with you, but if you want to do it on your own and then sort of check your work, you can certainly do that. So I have my scores here. We have a 4, a 2, a 6, and a 4. So our first goal is obviously to find the mean. So when we add these together, we get 16, and 16 divided by 4 is going to be a mean of 4. Okay, so we know our sample mean is a 4. Now our quest becomes to find the variance, the standard deviation, the standard error. And so, in case you've forgotten, we get to do our fun little x minus m and x minus m squared charts. So that's what I'm going to be doing here. 4 minus 4 is 0, 2 minus 4 is negative 2, 6 minus 4 is 2, and 4 minus 4 is 0. Remember, make sure that middle column adds to 0, which it does. And then you're going to square those numbers. So 0 and negative 2 squared is a 4. And when I put that in my calculator, remember I'm just going to put a 2 squared because sometimes the calculator does not treat the negative correctly if you don't put it in parentheses. So then 2 squared is 4, 0 squared is 0. And so when I add those together, I get an 8. So that's where I'm at right now. The 8 is the sums of squares, right? So don't forget 8 is sums of squares. But we are working through our variance and all that. So for our variance, we take that sums of squares, that 8, and we divide it by n minus 1. Oh, I'm probably going to need a calculator. So, because my n is 4, so I'm having to take that 8 and divide by 3. So hold on 1 second. Okay, 2.67. So our variance is 2.67. Showing you where I'm at here. My variance is 2.67. Now I'm going to do the standard deviation. So you know I'm going to take the square root of the variance. And my variance was 2.67. So, oh no, I'm going to need a bigger calculator on my computer, so calculator options are not the best. Let's see. Okay. 2.67. Okay. Square root of 2.67. Okay, 1.63, so that's the standard deviation. And we need the standard error. Because remember, you're not done with step 2 till you've got your standard error. And that's going to be your standard deviation divided by the square root of n. So for us, that's 1.63, because that's our standard deviation, divided by the square root of 4. So I'm going to do my 1.6. Stop. How do I clear this sucker out? I'll just refresh this page. Okay. 1.63 divided by 2. Okay, 0.82. So that is the standard error. Going real slow because of this calculator situation. Okay, so I sort of call this whole thing step 2. Step 3, we're supposed to find our cutoff scores. Remember, you need your 3 pieces of information. A p-value, which I didn't give to you yet. So let's say 0.01. This, is it one-tailed or two-tailed? We're doing a one-tailed test because we were saying that people in the running club would be less anxious. And we need the degrees of freedom, which is a whopping 3 because we only have 4 people here. So we're doing degrees of freedom of 3, one-tailed 0.01. Wow, that is a really high cutoff. So our cutoff is 4.541. So that means that the t that we're about to calculate has to be higher than that in order for us to reject the null. Okay, so tricky thing here though is you got to figure out which side you're going to put it on. So we thought that students in the running program would be less anxious. So we're going to actually put this cutoff on the left. And I just did that wrong, so I had to fix it. Okay, so here's where I am. Okay, so now we need to find a t value here. I'm kind of going to go up. I'm like all over this board, but remember in the t formula though, your mean for your sample, it's your mean for your sample minus the population mean. Do not get those mixed up. I saw some people doing that on the homework. So just make sure that you've got your mean for your sample minus the population mean. So for us, our sample mean was a 4 and our population mean was a 6. And we're dividing that by the standard error, which we found was 0.82. Okay, so now we're doing 4 minus 6 divided by 0.82. Okay, so it should be negative 2.44. And does that pass our cutoff? No. No, it does not. You see that? It does not pass the cutoff. It is not high enough to make it into what we call the region of rejection. So that means for step 5, we will fail to reject the null. Fail to reject. Okay, the only thing I don't have on here is the effect size. No idea where I'm going to put that. Remember, the effect size is going to look just like the t formula, except you're dividing by the standard deviation. Yeah, right there. And not the standard error. So you're dividing by the, what was it, 1.63 instead of the 0.82. All right, hold on. Let's see if I can find a place to put it on here. I'm going to put it over here. D. All right, so 4 minus 6 is still on the top. Minus 1.63. All right, so that's going to be 2 divided by 1.63. be a negative 1.23. Negative 1.23. Where's that? Right there. Negative 1.23. Now remember, for our effect sizes, what's small, medium, and large? So for this one, this would be a large effect size, right? If you need just a refresher, small effect sizes go from 0.20 to 0.49. Could be positive or negative, doesn't matter. Medium effect sizes go from 0.50 to 0.79. And large effect sizes are 0.8 or larger. And we've had a lot of large ones, like ones that are over 1. But it's nice for us. It doesn't always happen like that in our real research, though. So this is a large effect size, even though we're not rejecting the null. Remember, that can happen quite frequently when you have very few people. So it's a big effect we're seeing for those 4 people, but we cannot trust that that would not just happen by chance because it's 4 people. That's sort of the problem here. Anyway, there's the whole thing if you need to check your work. If you have any questions, just email me, and I'll talk to you later. Bye.